All right, guys. I think we can join back. I'm so sorry. I am so sorry. That kind of call, the person called the wrong time. The call came in the wrong time. It wasn't really Nigeria network this time around. It was the call. So let's join back, please. Yeah, welcome back. Sorry for that. It wasn't really network. It was just someone that called me the wrong time. I'm so sorry about that. So let's get to business. Please share the link with others. Let me try to do that too. So we can continue. We have 30 questions to solve. We've solved only one. So we have a long way to go. Very long way. A very long way. So let's join back as soon as you can. Don't forget, before you open the chat, give the video a thumbs up. Thank you. So once we have more people join, I will start. I don't want to leave anybody behind. Thank you, Edet, Destiny, Sufficient, uh, Big, Eniola. You are all welcome. All right, it's like the population is increasing. Thank you. Don't forget, give the video a thumbs up. You will not die for doing so. Thank you. Don't forget to give uh, the video a thumbs up and right before you open the chat. So let's get to business. In summary of the last section, we've talked about computer classification based on signal, where we have digital, analog, and hybrid. Thank you. So let's move to the next classification, which is by purpose. Depending on their flexibility in operation, computers are classified either as special purpose or general purpose. Depending on their flexibility. These are potential things they can use for question. You know already by now. You've done some exams, so you know that anything can be a question from your material. So that is the thing. Let's answer that very funny question. Depending on their flexibility in operation, computers are classified as either dash and dash. So since we have two classifications based on purpose, which is special or general. What are those computers we call special purpose computer? A special purpose computer is one that is designed to solve a restricted class of problems, not just a general problem, a restricted class of problem. And those kind of computers, they are more focused because they are just meant to solve one particular aspect of a challenge, or one particular challenge, or one particular problem. Now, such computers may even be designed and built to handle only one job, like I've mentioned earlier. Only one job. So in such machines, the steps or operations that the computer follows may be built into the hardware. Since it's only one job that the computer is doing, the computer will be very smart. You guys have not answered my question enough. Okay, I have another one for you. So try to answer this one too. Let's see if you have been following. Now, a special purpose computer is the one that is designed for restricted class of problems, and then it's more precise. It follows just one, since it's most of them solve only one single sorry, what am I saying? Only one specific problem. They don't solve more than that. So mostly their operations are always in the hardware. They are built in the hardware. Most of the computers used for military purposes fall into this class. The military computers, the computers used in programming all those their rockets, their no, rocket is not even the military. All these their missiles, or what do they call it? All those weapon of war. The computers they use in programming them are mostly special purpose computer. Other example of special purpose computers include computers designed specifically to solve navigation problems, the GPS computers. Computers designed for tracking airplane or missiles, they are all special purpose computers. Now, computers used for process control application in industry such as oil refinery, that means the kind of computer that automate the processes that operations takes in, like in a place like oil refinery, like maybe from extraction to refining to washing to separation to, those of you that are into science, you know that you've done that a bit in chemistry or so. So there is a computer that automates that process in the oil refinery. It's a special purpose computer because all that computer will do all its life is just automating the process of refining oil. It doesn't do anything. That is the only thing it is meant to do. That's why I would say special purpose. They are meant for this particular purpose. So we've mentioned many examples of them. The one used in military, the one used to solve navigation problem, the GPS, the one used for tracking airplane or missiles, like uh, in the airport or so. The ones that they use in the industry, like in oil refinery and the rest of them, for chemical processes and the rest of them, and even the ones they use in chemical manufacturing industry, they are all special purpose computer. And the one they use in robotic engineering or in robot factories, they are all special purpose computer. They deal with just one particular thing. So the one they use in automating or creating the behaviors of robot in robot factories now, the only thing it does all its life is to be creating characters in robots. So that is one thing you need to know on special purpose computer. They are mainly used for some specific purposes, restricted purpose. Now, we have the second one under classification on purpose. Um the second one is general purpose. Just give me 1 minute, you see it now. I want you guys to answer that. Let's see how far you people have gone. So the second one is general attributes of special. Okay, we are not on the second one yet. Oh, I think my screen is no longer showing. I will need to share that back. Those of you that are here to give my, you want me to end the video, Abby? Please, so give it a thumbs up. I believe I'm sharing the screen back, so it should be showing now. Now, what are the things general purpose computers do? Special, also a special purpose computer, what are the attributes they have? Special purpose computers are usually very efficient for the task for which they are specially designed. Yeah, tasks they do every day. Even you as a human being, they say consistency is key. If you are doing one thing every day, that is the same thing you are doing, you become a master in it. Like you won't be able to do that thing in dream. If they just tap it, pa, 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 even in dream, you'll be able to do it. That is because it's only that thing you have been doing. It's just a rotary motion. Everything is circular. It's the same thing you are doing every day. They boot you, you start programming robots till night, they switch you off again. Next day they switch you on, you start robotic engine. So for that sake, for that reason, it's all those kind of computers are very efficient in what they are meant or they are programmed to do. They are very much less complex than the general purpose computers. The reason is that since it's only one thing they are meant to do, maybe the only thing that will be on them will just be one application that is in charge of that thing they are meant to do. It's not like your general purpose computer that you have game, you have YouTube, you have browser, you have this, you have that. You sometimes you switch on your computer itself, you get confused of which one to what to touch first, what to start work on first, because those ones are general purpose. Quite a lot of things are on them. they multitask, they do different things. But these ones that are special purpose computer, it's only one thing they are doing. So they are not that complex. Once you on them, what they are there to do is always the only thing you will see on the screen. So now they are very much cheaper than the general purpose type, since they involve less components and are less complex. You may think that they should be the one that should be uh costlier, but now they are the cheaper. They are the cheaper one. They are cheaper than the general purpose. And I think the reason is, since it's only one thing it can do, it become easy. So they only design them for this particular thing, and that is the only thing they'll be able to do. That is the main reason why they are cheap. What are the attributes now? They are efficient for the tasks they are created to do. Number two, they are less complex. And number three, they are cheap. Don't forget, when you see the list items like this, these are potential questions. They will not, they, in your obj tomorrow, they will add one, or they will twist one of them incorrectly and say you should fish out the one that is not part of the attribute of special purpose computer. Okay, I want you guys to list them in your chat box now. The three attributes, they are the general purpose, the three attributes of the general purpose computer, which we've mentioned here: efficiency, less complex, and cheap. So once you remember those three, anything they add tomorrow that is not part of it, you should be able to fish it out. They are efficient, they are less complex, and they are cheaper than the general purpose. After that, we'll move to the general purpose computers. After that, we'll move to the general purpose computers. And for the general purpose computers, those are computers designed to handle wide range of problems. The computers designed to handle wide range of problems are called the general purpose computers. Now, this is the type you use, the type you have your laptop, where you have some of you, your laptop, all the games that are in this world, even the games that I see doing in the lab, you're already testing it, the meta version, because you like games. You have different things. You are into graphic design, you are programming, so those ones, they are general purpose. They have quite a lot of features, a lot of applications you install on them. And those are the type that are good for several uh, activities, such as uh, in banking and finance, in payroll, when you want to, you know, uh, come up with the payroll of your organization, in the banking section, in billing, you use them in billing, in sales analysis, cost accounting, manufacturing scheduling, inventory control. All these are examples of places where general purpose computer can feature. Anywhere you can think, anywhere you feel like they use a computer that can do different things, not just one thing, then you know that general purpose computer can fit in. You understand? So then the general attribute, just like we had three attributes for the special purpose, which are efficiency, less complex, and cheaper. Now let's see the attribute of general purpose. The general purpose computer, they are more flexible than special purpose computers. They can handle a wide range or spectrum of problems. They are less efficient than the special purpose computers due to the following problem: inadequate storage. Since they deal with a lot of things, storage issue is there. The first one is that they are more flexible than the special purpose. Why? Because they have the capacity to handle several things, different type of field. They work in different type of field. So another thing is that they are less efficient. And why are they less efficient? Due to inadequate storage, low operating speed, because of too much work. The speed may be slow than the specific, like the one that is just for special purpose. Once you boot it, everything will be fast because it's just one thing it does. So the speed is fast, but the general purpose that is doing a lot of things, the speed is not that, is not as fast as the special purpose. So inadequate storage, low operating speed, then the coordination of the various tasks and subsection may take time, and also that means it is time consuming. The general purpose computer is time consuming, it has low operating speed, it is inadequate in storage, and then the general purpose computer are more complex than the special purpose computer. Now we have four attributes. Yes, or we have just two, and then one of them is having subsections. The two attributes of general purpose computer that we've mentioned is that flexibility, one, and second one is less efficient. They are flexible and they are less efficient. Those are the two main attributes. But the reason why they are less efficient, that is why we have inadequate storage, low operating speed, the coordination of the various tasks is time consuming. So you can just say that one, that point three, we can just say it is time consuming, and then they are more complex than the special purpose computer. Then classification of computers according to capacity. This is the main place that brought us here. The question from TMA was gotten from this particular place, but we had to read the whole unit to understand everything around that question. Classification of computers according to capacity. In the past, the capacity of computers was measured in terms of physical size. So I believe you guys haven't forgotten about classification by signal and classification by purpose. The last one is classification by capacity. So today, however, the physical size is not a good measure of capacity, because the modern technology has made it possible to achieve compactness. And what we mean by compactness is, you can see your laptop now very small, but it's doing the same thing a computer of those days that is as big as a room will do, or even more. It's even doing more now. So the compactness, the modern technology they are now using, all these transistors and the rest of them, has now made everything small. That thing that will be very big before is not only in computing, in all aspects of technology. They are now working on compactness, which is just space management. Everything they are doing now in engineering, also in technology, they are always trying to make space smaller for it to consume less space. It's like we don't have space again in the world. I don't know. So because the modern technology has made it possible to achieve compactness. So that is the meaning of compactness in that regard. A better measure of capacity today is the volume of work that computer can handle. This is actually what brought us here. There is a question in the TMA, and that question reads thus. That question says, excuse me, let me look for it. Okay, the question says, presently, dash of work that a computer can handle is a better measure of computer capacity. That was the question that brought us right here to all we have been reading since. So you can see, if you have been doing your TMA well, and just one question took you this long to finish because you are trying to use it to read, you would have been doing well. So you should learn these tactics for your next semester. Even those of you that don't have time to do TMA, I used to encourage you guys to beg those your agents to help you with the questions. I know it's not easy for them, because some of them, they actually do the TMA on phone. It's not everybody that has a PC. Even most of those agents you are giving, most of them, they are also using phones to do it. So it's not going to be easy for them to extract the questions. But if you are lucky to do it with people that have computer, beg them to help you with the question. It's not because you want to start doing TMA to yourself, or because you want to spoil their work. It's because you need those questions. Those 30 questions you are seeing alone can help you cover your material easily, that you will not know. With fun, you will just be reading, you see you are done with your material, no matter how big the material is. So please, that is a tip for next semester. This semester is gone already. Okay, let's move on, guys. So a better measure of capacity today, what we are just trying to say in essence here under classification based on capacity, is that in the olden days, in the past, they usually look at the size of a computer to show its capacity. So if your computer is very big, like the head of a cow, they will say this one is a big computer. That is how they measure capacity in the past. But in our modern days, based on the advancement in technology, because technology is now pursuing making things smaller, but even to work smarter, they are now using the principle of compactness. So in this our age, in this modern age, we cannot say that the size of a computer is what shows the capacity. Rather, the volume of work your computer can perform is what shows the capacity in this modern age. Very important. Now, the volume of work that a given computer handles is closely tied to the cost and to the memory size of the computer. Therefore, most authorities today accept the price of rental price as the standard for ranking computers. Memory size and cost shall be used to rank or classify computer into three main categories. So, uh, I'm going to ask us a question. Since we are now saying that two things are now used as yardsticks to check the size of a computer, so those two things, when we put them into consideration, we are going to get three categories of computers under capacity. I have a question for you guys. Kindly answer that question. Everybody online, let's see if you are following. Answer that question. Let's see if you are following. The question says here, comma, both dash and dash shall be used to rank or classify computer. Now, into three main categories. We have, based on size now, we have the microcomputers, the medium or mini or small computers. Now, when you see things like this in the material, it's good you put your mind there so that tomorrow when they ask you that a medium computer is also known as dash, you'll be able to answer. Okay, let's test ourselves. Let us test ourselves. I want to see how you guys will approach this. I'll hold on a bit. I want to see your responses. Okay, sorry. I want to see your responses so that let's open our eyes to things today. Okay, look at that question. A medium computer is also known as dash. In the material, we have two other options. You can call them. So if you want to answer that question, what will you write there? Will you just write one of them or you write the two of them? That is what I want to check. Oh, I want to see. Okay, Docs Malik, mini or small. Insikat says small computer. Okay, Damilola says mini stroke small computer. Sadiq is going for mini computer or small computer. Well, all I want you guys to know is that if you have two other options there like that, make sure you mention the two of them. That is the main point. Okay, so we have microcomputers, medium, or we call them mini computers. Mostly they call them mini computers. All these medium, small, they are just alternatives, but the most uh, common one they call them are mini computers. And then we have the large computer, which are the mainframes. Okay, let's check this. You guys are doing well in that one. But I have another one. Oh, sorry, that's my question. Don't mind me. Oh. Just take it. That my also is not correct. My hands are I've been just take it like that. It's also I want to write there. So microcomputers, which is the first one under the category. Microcomputers are also known as single board computers, are the cheapest class of computers. In the microcomputer, we do not have a central processing unit as we have in the larger computers. Rather, we have a microprocessor chip as the main data processing unit. They are the cheapest and the smallest and can operate under normal office condition. The examples of microcomputers are the IBM, the Apple, the Compaq, the HP, the Dell, and the Toshiba. I have two questions I'll ask you here. I'll ask us here. Mm, okay, let's fill in the gap. And then I also want to ask us a very similar question because most of us will be HP, my laptop is HP. You go to the market to buy a laptop, you say, I want to buy HP. It's HP I want. What's the full meaning of HP and what are the examples of computers? Okay, so we have the Dell, the Toshiba, and then the Dell, Toshiba, anyone. Now, different types of personal computers, which are the micro computers. In other words, the personal computers fall under micro computers. The personal computers fall under micro computers. The personal computers fall under micro computers. Now, normally, personal computers are placed on table desk, hence they are referred to as desktop personal computers. Still, other types are available under the categories of personal computers. They are laptop computers, which are small size types that are battery operated. The screen is used to cover the system while the keyboard is installed flatly on the system. You all know laptop. You don't need to drag on that. We have the notebook computer. I think I'm rushing. Excuse me. Sorry. We have the notebook computer. This is like a laptop computer but smaller in size. Although it's small, it comprises all the components of a full system. That means everything a system can do, a notebook computer can do it. A palm top computer is far smaller in size. All the components are complete as any of the above mentioned, but it is smaller and can be held on your palm. It is still a computer. Then we have the uses of personal computers. Under uses of personal computers, anything you know you use your laptop to do fall under the uses of what? Personal computer. I don't need to stress you on that. Anything at all you know you use your laptop to do, or you know that people that have laptop use them to do, like, okay, let's go through them a bit. They can be used to produce documents like memos, report, letters, and brief. Now, if you ask tomorrow that which of the computers are used to produce memos, reports, or whatever, you should know those are personal computers. They can be used to excuse me, calculate budget and accounting tasks. They can analyze numerical function. They can create illustrations. They can be used for electronic mails, your emails. They can help in making schedule and plan project. Can assist you in schedules and plan project and so on. Anything you just think you are using your own personal computer, your laptop to do, they all fall under this category. What are the advantages of having a personal computer? One is that computer is versatile. It can be used in any establishment. I want you guys to check the meaning of versatile. We have been hearing computer is versatile since we were in primary school. One of the advantages of computers given to us when we were still in primary school was that computer is versatile, even though then you don't even know what versatile means. So check it now. What is the meaning of versatile? Because I know some of you don't even know it. I will just think that everybody knows it. So let's check it today and learn it in case you don't know it before. What's the meaning of versatile? Dora, you are welcome. I've been asking, I don't know where you've gone to before. Regina, my member subscriber. Thank you, Regina, for joining us. I don't know you are here. Your name is highlighted in green. That is one advantage of members. Those of you that are not members here, join. You know that it's just 3K. Okay, flexible. Thank you, Big Enola. Big Enola is giving us a synonym to versatile. Versatile to her means flexible. And for Insikak, versatile means able to do many different things well or easily adaptable. Well, that's okay. So guys, it is versatile, which means it's flexible, has faster speed. Oh, I think I have mistakenly pressed something. Sorry about this. I have mistakenly pressed something. Let's get this thing off our screen. Adobe want us to give them money. We are not giving you any money. You better leave us alone. Now, has faster speed for processing data. Those are personal computer. You can deal with several data at a time. You can multitask at a time. Can attend to several users at the same time. Those are all advantages. Then they are capable of storing several data. Like some of you now, if you open your PC, all the movies that, like some of you that like horror movies, all the horror movies they produced since 2000 to date, you still have them in your system. Why? Because you like going back to some of them sometimes. So it's because the computer can store several data, can store not only movie, it can store songs, it can store pictures, it can store documents, store anything. Then operating of computer is less fatigue because since you can carry it anywhere. It's not like before that computer they were only desktop. It has to be on desk and you have to just sit down in one place to operate. But now inside your bag, you just put it anywhere you are, you can just sit down, open your laptop and start working. And also network possible. That is linking of two or more computers together. Your laptop, like in my room here now, I have quite a lot of laptops. I can connect them. So I have my own remote connection in the house that all my computers, they do communicate to each other. I can access my computer B from my computer C or from my computer A. That is just a remote local area network connection. That is possible with personal PC. Now, disadvantages of personal computers. Computer is costly to maintain. It is very fatigue and complex to handle. It requires special skill to operate. So we'll go to mini computers. Don't forget that the first type of computers we talk about were the microcomputer, but the major example given under it was the personal computers. So when you talk of micro computers, your mind goes straight to your laptop, your personal computers that you operate, your palm top, your notebook, your laptop. So the second type we will talk under capacity are the mini computers. And there is this question in TMA that was also from this unit. The question says, the dash computers have memory capacity in the range of 128 kilobyte to 256 kilobyte. I don't know if some of you still remember the question, like those of you that did the TMA yourself, you know that you met this question. In fact, in most cases, they repeated it twice. In one version of this question, they cut out the mini. In the second version, they cut out 128K and 256 kilobyte. So I'm not saying that it will come out in exam. I'm just reminding you. You understand? So let's answer the two questions we have there. All right, so guys, the mini computers, that is the memory range. They are not expensive. Likewise, just okay, they are not expensive, but reliable and smaller in size compared to mainframe. Mini computers, they are larger in size than the microcomputers, but they are not as big as the mainframe. So it was first introduced in 1965 when DEC, Digital Equipment Corporation, thank God, we started entering filling the gap. What is the full meaning of DEC? I want you guys to do this. Write it. Don't say somebody have written it. Write your own. It will help you to remember tomorrow. Now it was introduced. Okay, I have another question. That is another question for you to answer. Okay, so in 1965, and then that was when DEC, which is the Digital Equipment Corporation, built their PDP, PDP-8, and other mini computers, which include Wang VS. Okay, I have another question. Don't mind me. I'm just using that question to engage you guys. Oh, sorry, those questions to engage you guys. Okay, that is another one. Okay, so after mini computer, you don't really have much to remember on mini computers. Just know that number one, they are larger than the microcomputers. Number two, their memory size ranges from 128 KB to 256 KB. Number three is that they were introduced in 1965. Number four is that 1965 was when DEC, which is Digital Equipment Corporation, built their PDP-8, and other example of those mini computers are the Wang VS. Now, the last one under this unit, and after reading this, we have completed one full question from your TMA. Now, the mainframe. The mainframe computers, often called number crunches, have memory capacity of the order of 4 KB, and they are very expensive. Very expensive. Let me read that line again. The mainframe computers, often called number crunches, have memory capacity of the order of 4 KB, and they are very expensive. I have something nice for you guys. You will love it. I want you to fill in the blank space. There is a question dropping shortly. So fill in the blank space and let's see if you guys have been following. Those are mainframe, the big computers. They can execute up to 100 is that meanwhile instruction per seconds. Oh my goodness. Here is another thing to note. Every abbreviation tonight, we will try to learn them. So these are ways they ask it. All right. Questions are dropping. So you keep the answers coming. Quite a lot of people have not given my video a thumbs up. Please do so. I'm begging you guys. Give it a thumbs up. Just go to, what's it called? Close the chat. Quickly give it a thumbs up and come back to the chat. Now, they have large systems and are used by many people for a variety of purpose. And I think after that, we are done with this unit. Hallelujah. We are done with question one. How many minutes did we use in studying or answering just one question? We used 40 minutes earlier. This is 30 minutes. That is more than 1 hour to answer one question. So it means for the 30 questions we want to answer now, we're likely going to use 30 hours here tonight. Hey, God help us. What will happen is we will answer 2 more questions, then we'll go on a break. We'll continue in the night. Because I know you guys need to attend to. Some of you are just returning from work. You need to cook and eat. Like Dora now. Dora just returned from work, and Big Eva is already waiting patiently, waiting with his eyes are already red. Hunger. When will this madam come back from work? Big Eva is a boss. They are working for him in office, so today he decided not to go to office. So those of you that will cook for daddy and mommies, we need to release you. Then we'll start as early as 8:45 by God's grace. And I'll try to get fuel so that in case we will not have light, because my PC is low, so that we will stay there till like 12 a.m. Then we'll release you guys so that you guys can relax. The reason why I'm going to take you that long is that I want to touch everywhere we can touch by answering the remaining questions. You understand? We'll touch everywhere so that even if you not read again after the general reading together, you will still be able to pass your exam tomorrow by God's grace. Now, conclusion. Computers are classified based on three major criteria, namely size, type of signal being processed, and the purpose. The classification adopted at any point in time depends. What is wrong with this one that is just popping up like this? Oh, this is really annoying. Sorry. Okay. I have a very long question for you guys while I clear this sheet up. Please kindly answer that question from the material. I'm sorry about this one that is stopping us. Now, the classification adopted at any point in time depends on the issues involved. For instance, if our goal is to process different kinds of signals or to accept one type of signal and convert to another form of signal, we should look into the realm of analog or digital or even the hybrid computers. This, of course, calls for a converter such as analog to digital converter or digital to analog converter, as the case may be. In summary, in this unit, we have been able to understand the following. Computers could be classified based on three major criteria: the size, the type of signal being processed, and purpose. Based on size, computers are classified as mainframe, mini computers, and microcomputers. Based on type of signal processed, computers are classified as analog, digital, and hybrid. Based on purpose, computers are classified as general purpose or special purpose computers. And microcomputers now come in different forms due to continued reduction in size due to advances in electronic technology. Microcomputers could be desktop, laptop, or palm top. So God has brought us to the end of that question. Let me see question 2. Let's quickly take question 2 before we round up tonight for the first section. So the second question says, dash is a finite sequence of operation which gives unambiguous method of solving a problem. So that question will lead us to an entirely new unit. In fact, TMA is awesome. TMA is awesome. I just pray you people will see into what I'm saying. You will see what will happen. You will see the difference between this course and the GS101 that you've done earlier. I know this course is very tough for those of you that are not in the science class, but we are not hoping it's going to be tough for anyone because you are reading already. Just make sure your mind is set. Look at it. This is taking us to algorithm. The answer to that question is actually algorithm, but we will not just read algorithm and run away. We will read everything around algorithm. We'll study it back to back. We'll study each of the diagrams that are used in. We'll study flowcharting. Oh my goodness, we have a lot to study here. Hey, I hope I will not drag you guys into the night much. What will happen is, well, let's read a bit on this first. Now, the O unit is study unit 3, where we'll talk about flowchart and algorithms. Flowchart and algorithm. Now, these are deep computer terms, especially for programming. Oh, what is this? So, Biko. So, don't be tired, guys. Don't worry, we'll soon be done. So, flowchart and algorithms, table content. We'll talk about flowcharts and algorithms. the introduction. In this unit, you are introduced to the principles of flowchart and algorithm. Now, this, okay, sorry, I think I need to reduce this a bit. The importance of this concept are presented, and the detailed steps and activities involved are also presented. The objective is that by the end of this unit, you should enable the student to grasp the principle of good programming ethics through flowcharting and algorithm. Now let's study this word flowchart. What does it mean? A flowchart is a graphical representation of the major steps of work in progress, or sorry, in process. A flowchart is a graphical representation of the major steps of work in progress. That is the work of a flow chart. That is the work of a flow chart. Like those of you that are into programming, you know what we're talking about. Sometimes you need to design what you want to program using diagrams. I have a very short question for you guys there, so try to deal with it. It displays in separate boxes the essential steps of the program and shows by means of arrows the direction of the information flow. The boxes, most often referred to as illustrative symbols, may represent document, machines, or actions taken during the process. The area of concentration is on where or who does what, rather than how it is done. A flowchart can also be said to be a graphical representation of an algorithm. That is, it is visual picture which gives the steps of an algorithm and the flow of control between the various steps. Okay, I will need to use something to teach us the diagrams that we have. We have quite a lot of diagrams. Sorry, not diagrams, symbols. I mean to say symbols. Give me 1 minute. Okay, all right, let's wait for this guy to finish. All right, so flowchart symbols. You know what a flowchart is. Let me repeat this statement again and again. A flowchart is a graphical representation of the major steps of work in process. A flowchart is a graphical representation of the major steps of work in process. A flowchart is a graphical representation of the major steps of work in process. All right, let's go to flowchart symbols. And that is, flowcharts are drawn with the help of symbols. The following are the most commonly used symbols. And your material did not really do enough justice. Your material just scattered everything. So I'm looking for a better way of representing them and showing you in a more, okay, I think, good. I will need to share another screen. Which is the screen I will be using to teach us the flow chart. I may not need to use that diagram in the material because I want you guys to truly understand it. Okay, let me share another screen. Just permit me 1 minute. We'll deviate from the material a bit. We are going to deviate from the material a bit. Now, as soon as my new screen is showing, you guys should let me know, please. So we'll start the main thing. I think I'll need to bring it up a bit. It's showing now, right? I need a confirmation from your side. Is the new screen showing now? Somebody is asking if this is computer. Well, this is the programming part of computer. It is actually computer. So don't get scared. Now, common flow chart symbols and their uses. We have the terminal, and the terminal symbol is used for start or end. That is to begin or to end the process. And the shape of the terminal is like an oval, the oval shape. I'm going to show us, don't worry. It shows the beginning or the end of a program or process. Example is start and stop. Okay, let me show us now. This is okay. Wait, let's view this image. Let's view this first image. Oh, I hope this image will come up bigger than this. Oh, no, no, no. Okay, I'm trying to bring it bigger than that, or probably we should download it and share the screen. Ah, that is still very small. It is still very small. Okay, you know what I will do? How many of you are in the group? I will likely drop that image in the group so you guys can relate to it. Yes, I've dropped it in the group. That is a clearer version of it, but I think there is another thing we can also do. Okay, let me share it on another screen so we can use this to get it better. As soon as you are seeing it on the other screen, you let me know. Okay, I think the other screen is showing now. Now you can see the symbols. The one that means start or end, which is the terminal. This is the one we call terminal, and the symbol is like oval shape, and the name is terminal actually. And what it does is start or end, and the function is an oval which represents a start or the end point of the process. Then the arrows. What do we use the arrows to do? We use the arrows to connect. They are connectors that connect the different shapes. Okay, a line is a connector that shows relationships between the representative shapes. I answered this question in my own set. Yes, I remember. They asked me a question on arrows, on parallelogram, and on diamond. Those are the three that came out in my own set. Arrow, parallelogram, and diamond. They are those shapes. What are they used for in flowcharting? So a line is a connector that shows the relationship between the representative shapes. Now, we also have the input or output, which is the parallelogram. The parallelogram is used for input output. The parallelogram is used for the input or the output, and this is the shape of the parallelogram. It is used for input output, and this is the shape. We have process. The process is a rectangle. A rectangle is one that represents a process. So when you see a rectangle in any flowcharting logic, that one is showing that a process is ongoing. Process. So a diamond, which I said they asked in my own set, it is used for decision making. Diamond represents decision. A decision is to be made here or is to be taken here. So those are the basic ones. The diamond for decision, the rectangle for process, the parallelogram for input or output, arrows, connectors, and the terminal or oval for start or end point. All right. So having done this, I believe we have done some justice. So I also like to do something now. Show us an example of a flow chart, a practical example of a flow chart. I'm going to show us now. I believe my new screen is showing. So let me drop the second image in your group. Let me drop the second image in your group. And of course, that second image is an example of a flow chart. The start, you can see the symbol. That is a complete flow chart. Excuse me, let me share it here so you I don't think there is any need. It's okay like that. You can see it even on that screen I'm sharing. What you are seeing there is that we are having the start, which is the parallel, the oval, the terminal, which it means start or stop. In this case, it is start. You can see that the connector, which is the arrow, is also called line, is connecting start to process, which means after I have started, I initiated a process. The arrow is connecting them to show that this is the direction of flow, and this is from start to process, and from processing I will have a decision to make, because the diamond represent decision, and from making decision I can have output. Don't forget that. Okay, sorry, I can have processes also, more processes which are now more, what do we call this, rectangles, more rectangles to show more processes. So from start to processing to decision, and then the thing can go on and on and on until you get to the last point. Now I have another image which I am going to use to show a complete flow chart. For instance, I want to program, and I actually want to use a I want to use sorry, what am I even saying? I want to program something, and then I need to do the flow charting. Look at that, is a complete image for the flow charting. Okay, so if you look at that image very well, it's very tiny there, and I've dropped it in the group. I think the class captain, those of you asking for a group link, they will help us to drop it. Although if you are not in mass comm, you may not enjoy the group. Well, you enjoy it for the general courses, but every other thing that will be done in that group will be for mass communication students alone. So in the group, I will drop the link here now. You can join the group and make the best of those diagrams to understand flow charting. So let's go. Guys, I think so. We have done justice, and then there are other uh shapes, or yes, there are other symbols that we have here. That's the one we have on my diagram there is not capturing. So let me share your material. Let's quickly look at two of them. The one that look like a circle. A circle is used to identify junction point of the program. Junction point of the program. Which other one was not used in the one I used there? Then we have the trapezium. Yes, we have the trapezium, which is used for entry or exit from a page. This one is what we call trapezium. I think it's used for entry or exit from a page. Okay, and I think that is all on that. Then we have general guidelines for drawing flowchart. How do you draw it? Like the one I dropped in the group now, you'll be wondering, what are they drawing? What is all this? What is the connection? Now, each symbol denotes a type of operation. The operation can either be input, output, processing, decision, transfer, or branch, terminal. So that is one thing you should know, that each of those symbols you are seeing there represent an operation. I have a very short question for you guys, and I will soon release you guys seriously so that you will be able to relax a bit before the next section. Don't forget, we have 28 more questions to go. A note is written inside each symbol to indicate the specific function of that symbol. Flowcharts are read from top to bottom. These are irrelevancies that they are likely going to ask questions on in exam. What you think is not necessary. So dash are read from top to bottom. Like the one I drop in the group now, when you want to start reading it, you are definitely to start from the top, not from the bottom or sideways. Now, a sequence of operations is performed until a terminal symbol designates the end of the run or branch connector transfer control. Now, flowcharting the problem. Now, if I want to flowchart a problem, if I want to flowchart a problem, the digital computer does not do any thinking and cannot make unplanned decisions. Every step of the problem has to be taken care of by the program. What we are saying is that all these computers you are using, if there are no precise programming, they cannot they cannot think. Well, we are having artificial intelligence now, where they can actually think on their own a bit now. But all these digital computers we have, most of them cannot think on their own. So what happened is, even till now they can't think on their own because everything must have been laid down. So if you want to use a computer to write an algorithm now on how to brush your teeth, you must specify every action before, because your computer don't know how to brush your teeth. But you must specify every action. That maybe number one, you have to get to the toilet or wherever you do your own. Number two, step two, you have to get a toothbrush. Step three, you have to get a paste. Step four, you have to open the paste. Step five, you have to spread some quantity of the paste on the brush. Step five, you have to turn on the tap. So you have to precise all the steps, every single step, before your computer will now be able to answer a question on how to brush your teeth. That is the meaning. That is why we have all this algorithm of a thing. So you have to tell your computer every step it takes to brush your teeth. So all this thing that you guys are saying now, you just ask your computer or your AI something, it has answered. It's because they've given it all it needs, every step involved, to give you the tip on that thing. That is one thing you need to know. So a problem which can be solved by a digital computer need to be described by an exact mathematical equation. You cannot be programming a computer and be guessing and be saying, well, if this thing is like this, just do like this, or kind of. You can't do that. It has to be exact. You have to tell it every step on the way to getting to the solution. Now, but it does need a certain set of rules that the computer can follow. If a problem needs intuition or guessing, or is so badly defined that it is hard to put into words, the computer cannot solve it. This is a very valid or important statement, and I think we need to register that. So let me ask us a very simple question, probably the last question in this section, because I want to see if you guys are. So I have a fill in the blanks here. So let's answer that, guys. So a computer cannot solve it. A typical flow chart consists of special boxes in which are written the activities or operations for the solution of the problem. The boxes linked by means of arrows which show the sequence of operations. The flow chart acts as an aid to the programmer who follows the flow chart design to write his programs. That is all on flow chart. Don't forget the meaning of flow chart, the definition of flow chart we've given. Then we have algorithm. After taking the meaning of algorithm, we'll stop this section. So before a computer can be put to any meaningful use, the user must be able to come out with or define a unit sequence of operation or activities in a logical order, which gives an unambiguous method of solving a problem or finding out that no solution exists. Such a set of operation is known as algorithm. That is why the TMA question asks by saying dash gives an unambiguous. I'll ask you that question again so you will see the way they ask the question in case it's likely going to repeat in the exam. Look at it. Dash gives an unambiguous dash is a finite sequence of operations which give an unambiguous method of solving a problem. That is an algorithm. That is an algorithm. Okay, so that is the definition of algorithm. Just know it like that. Now, to define it, an algorithm named after the 19th century scholar Abu Jafar Muhammad, that is IBN Musu al Khwarizmi, or what's this? Is defined as follows, roughly speaking. Well, this is a question. This is a question. How should I ask you guys this question? Okay, let's look at it this way. Let's look at it this way. Let me just ask you this way. Let's see if you have been following. So, we are almost done with question 2. Answer that question for your. Now, how did this man roughly define algorithm? An algorithm is a set of rules for carrying out calculation either by hand or a machine. An algorithm is a finite step-by-step procedure to achieve a required result. An algorithm is a sequence of computational steps that transform the input into output. An algorithm is a sequence of operations performed on data that have to be organized in data structures. An algorithm is an abstraction of a program to be executed on a physical machine model of computation. Guys, you don't need to cram algorithm. Tomorrow, if you see any question on algorithm, just try to remember something. This algorithm, what does it mean? Remember the idea of you wanting to tell your computer how to brush your teeth and how you have to tell it every step precisely what it has to do, number one, followed by number two, number three, the sequence it has to follow to solve that problem. So a way of programming your computer to solve problems, giving it the step-by-step procedure it has to follow to solve a particular problem, is what we call algorithm. Just know that. You don't need to cram it. So when you see anything that has to do with step-by-step preciseness or procedures in solving a problem tomorrow, your mind goes to algorithm straight. That is it. So the most famous algorithm in history dates well before the time of the ancient Greeks. This is Euclid's algorithm for calculating the greatest common divisor of two integers. Before we go into some otherwise complex algorithms, let us consider one of the simplest but common algorithms that we have encountered every day. Don't forget the man Euclid and the work he did. It's algorithm actually. Okay, let's check out that example of algorithm that they want to give us, and then we put an end to this section. Now, the classic multiplication algorithm. For example, to multiply 981 by 1234, this can be done using two methods or two algorithms. Methods of solving problems is what we call algorithm. Methods of solving problems is what we call algorithm. Like, we have this general algorithm that most of us do. We call it troubleshooting, which is brainstorming. When something happens, you first be you like maybe you have an issue with an electrical circuit in your house. Maybe your socket stopped working all of a sudden. The first thing you may likely be doing is troubleshooting. Okay, let me go and try another socket. Maybe that one is working, so that I will know whether it's this particular line that is having issue or my house generally. All you are doing then, you are using algorithm to solve a problem, but the method you are using is troubleshooting. You are trying to see which one is the main issue. You don't know the issue yet, so just put that in mind on algorithm. So multiplication, sorry, so the first way is multiplication in the American way. The American way, they multiply the multiplicand one after another by each digit of the multiplier taken from the right to the left, and this is the method that the Americans will use to multiply 981 by 19262. This is that method that you guys are used to. You are kind of used to. Okay, I think the one we mostly use in Nigeria should be the British. You know the way they taught us in primary school then how to do multiplication by hundreds and thousands. So the second one is by the British way. The British will multiply the multiplicand one after another by each digit of the multiplier taken from left to right, while the American will take it from right to left. The British take it from left to right. That is just the difference. American right to left, British left to right. Okay, what are the characters of an algorithm? Let's take it. That is the last thing. It must be a finite set or sequence of action. What it means is that an algorithm must have an end. Because if you say you want to solve a problem and you are giving your computer an unending sequence, an unending steps, how will it get to the solution? So an algorithm must have an end. That is what you are saying by a finite set. When you say something is finite in mathematics, we say it has an end. Infinite means no ending. So if you are giving your computer, you are teaching it how to solve a problem, the steps you precise or prescribe for it, or sorry, that you give to it rather, must end. It must have an end so that at the end it will give the solution. So first thing about algorithm is that they must be finite, and the sequence, or sorry, it must be a finite set or sequence of actions, which means when you do this one, then go to this one, then go to this one, then go to this one, and finally give the answer. So that is it. The second one is that this sequence of action has a unique initial action. The first step. Each action in the sequence has unique successor. This is what we are saying, which means when you complete step 2, then step 3 comes in. So without completing step 2, you can't jump to step 3. That is the meaning. They follow the sequence like that. You must start with step 1, going to the bathroom or the toilet. You must go to step 2, locating your toothbrush. You must go to step 3, locating your toothpaste, and so on and so. The steps must be followed. You cannot jump one step over the other. So the sequence terminates with either a solution or a statement that the problem is unresolved. What this means is that at the end of your sequence, there are two possible outcomes. Is either the solution to the problem, or if that problem does not have a solution, it's going to give you back that this problem cannot be solved. That is it. So we'll now be going to example of algorithm. Actually, that is where we'll pick up in the next class. And once we are done with that, we'll go to the next question, which will take us to an entirely new unit. I hope you guys understand how to use your TMA to read now. It's very smooth, and you do yourself some favor. The questions are already in the group. The 30 questions that they set for TMA this semester, we have it in the group already. Those of you that don't have anything you want to do between now and the time we will resume reading by 9 p.m., you can be using those questions yourself to go and be reading the unit where they are gotten from. Don't just go and look for the answer in the material. Read the whole unit where they set the question from. By so doing, it may not be that particular question that will come out in the exam. It may be another question from that same unit, so you'll be able to answer it. So I believe these 2 hours we spent together, you've learned a bit of the material, and it's really awesome. Thank you guys for joining. I wish you guys luck. The reason why we are not going to use any exam portal or any summary is that we want to test which one is better. In GS101, we have used exam, we used summary. You people were complaining quite a lot of questions, although I still have people that came to me and said that most of the things we did came out. So it's 50-50. But this time around, we want to focus on our material alone and see how far the material can help us. So help us, God. Okay, that is the link you're asking for. Do have a wonderful evening. See you by 9 p.m. Tell the rest of them that we will resume by 9 p.m. We will resume by 9 p.m. Grace is just joining when we are ending the class. Sorry. Bye bye, everyone.